Okay, we're given in the question that y is the arc sine of x. So in other words, y is the inverse sine of x, and we're asked to differentiate it. First step, take the sine of both sides. So sine y equals x. We're then going to differentiate both sides. So dx by dy, differential sine is cos y. Now our problem now is to write cos y in terms of sine y's, so we can introduce the x. We know that sine squared y, cos squared y equals 1, so we know that x squared plus cos squared y equals 1. So from that we can get cos y is the square root of 1 minus x squared. So we've got dx by dy is the root of 1 minus x squared, and therefore doing the reciprocal of both sides, dy by dx is 1 over the root of 1 minus x squared. Okay, so that's proved that. Proved as required, QED, one of those. Now we're given a different function. We're expecting to use this rule later on in the question, but at the moment we're given f of x equals 3x plus 2 over root 4 minus x squared, and we're trying to find the mean value. So in other words, we want the integral of 1 over the interval, which is root 2 minus 0, and of f of x dx between root 2 and 0. Okay, that's what we're trying to calculate. Now, we're going to have to split this somehow. So if the top isn't the differential of the bottom, it's not differential of the bracket, so we've got an issue. So we're expecting to split this numerator into two fractions. So if I do, if I write this as 3x plus 2 times 4 minus x squared to the minus a half dx, and that's 1 over root 2. Okay, so I'm going to split this integral into two. So I've got the integral of 3x 4 minus x squared to the minus a half, and then I'm doing the integral of 2 over 4 minus x squared rooted. Okay, now we notice this second one is very similar to part A. This first one is the differential of this bracket generates me an x term. Okay, so if this was f of x, this is some multiple of f dash of x. So we integrate the first bit, which is I get 4 minus x squared raised to the power by 1, which is a half. If I differentiated this, I'll get a half, and I'll get a minus 2x. So I'll get minus x, and I want 3x, so it's minus 3 at the beginning, so that works. Now this one, if I take, if I think of this, let's do a different colour pen, as divide, so I've got 2 over, if I take the root 2 times 1, sorry, root 4, apologies, take a factor of 4 out, minus x over 2 squared. So this is 4 times that will give me this, 4 times that will give me this. These two will cancel, so I'm left with the integral of 1 over 1 minus x over 2. So from part A, I hopefully can see I've got 1 over root 2 from the front, then I've got 2 arc sine a half x. Right, and the reason why I got 2 is, if I differentiate the arc sine, I get 1 over 1 minus a half x squared, which is this, times the differential of the bracket, which generates a half, hence I need the 2. I'll put the root 2 and 0 in. Okay, and just keep on going. So I get 1 over root 2 times minus 3, 2 to the power of half, plus 2 arc sine of root 2 over 2, plus 3 lots of 4 to the power of half, take away 2 arc sine of 0, which then gives me 1 over root 2 minus 3 root 2, which is the first term. Arc sine of that is pi by 4, so it's a pi by 2. That's 6. Arc sine of 0 is 0. So I end up with pi over 2 root 2, you might get there quicker than me, 6 over root 2 minus 3, which equals pi. Rationalise the denominator, multiply top and bottom by root 2, plus, same for here, 3 root 2 minus 3.